I'm back, and now we're going to continue our lesson. Less distractions here. So graphing three-dimensional coordinate systems. We're going to try to graph given x, y, and z, and where do the lines intersect at. So I just want to show how to construct the graph. Typically in 2 dimensions, like I was saying in the video, we have an x, y coordinate system, 2 dimensions. But what if we're going to graph 3-dimensional units? How are we going to do that? We need a z-axis. So I'm going to put a z-axis on here, so you have to use your imagination when you're thinking about this. The z-axis, the positive z-axis is going to come out at us. So imagine this is coming out of the board, and you can kind of see the 3D coordinate system taking shape. So this is a flat plane right here. I'm going to kind of make this line parallel, make this line parallel here. Like there's a shelf sitting right on top of there. So if this is the z-axis, going backwards into the back of the board would be the negative z-axis. Negative z-axis. So then we're going to plot points just like we would with a 2-dimensional coordinate system. If I'm going to go, let's come up with a point. 3, 2, 5. Systems always go x, y, and then z. So I'm going to go 3 in the x direction. 1, 2, 3. 3 in the x direction. 2 in the y direction. We're going to go up 2 from there. So we're not going to go up to here because going up 2, we're going to go up 2. So I have to estimate what that distance would be. About the same distance here. Go up 2 more. So right about there. Oh wait, we got to go 5 in the z direction. Okay, go 5 in the z direction. So now I'm going to go 5 in the z direction. So that's this way. 1. So let's go 1, 2, 3, 4, 5. Yeah? 3, and we're going to go over 5. So right in here. Oh, what? I did that wrong? Oh, you're right. You saw what I was doing wrong. Huh? It's not that complicated, Mr. Silva. So we're going to go think about, again, x and y. Where are they at? We're going to go up and down. I'm going to use different colors. Let's change this up. So let's go 3 in the x direction. X is 3. This is x. Here's positive x. 1, 2, 3. There's positive x is 3. 2 is y. Let's go up 2. And then 5 in the z. So we're going to come down this direction. This branch 5. So, you know, I put a dot on the graph. But you got to imagine that this is in space. This is a space place, right? What if we go in the negative direction? Negative 2, and then 4, and then 1. Something like that. Let's go 2 in the negative x direction. 1, 2, go negative 2, go up 4. Y is 4, so there's y. 1, 2, 3, 4. We're going to go 4. So this is 2, 4. Check. Got it. Okay. Negative 2, 4. Then we're going to go 1 in the z direction. So 1 comes out at us, so we're going to come 1 this way. So this is where we're going to be. So that point in space. So my essential question is, how do satellites or scientists find a satellite in space? Okay, so satellites usually are sitting at a certain distance away from the Earth. Okay, they're going to have an x and a y coordinate, just like GPS on Earth. But again, they're out in space. So in order to find that location, we would do something like this. We have a 3-dimensional coordinate system. So it's kind of hard to see on a 2-dimensional surface. That's if I have a z-axis coming out at me. So now if we have an axis that's not coming out at us, I want to make this slightly different. Let's make the x and y axis right here. Here's x, here's y. Now I want to make the z-axis go this way. So we can think about it differently. I'm just rotating this entire picture, this entire visual. 3 in the z direction, 3 in the x direction, 3 in the y direction. Okay? And again, we're going to go positive x, positive y, positive z, go up. And we're at a point in space. So if I'm at 3, 3, so we got to imagine like this is a grid. All the lines run parallel to each other. I'm going to go to 3, 3, 0. 3, 3, 0. 3 in the x direction, 3 in the y direction, 0 in the z direction. There we are. Three-dimensional. Now we're starting to feel like artists. This is pretty cool. So, graphene points anywhere in space. Where would the negative direction be? Going the opposite direction, there's negative y. Going back this way, there's negative x. And going down would be negative z. I'm just not going to include that on there. And what we want to do is we want to graph a system of 3 equations. So I got a system of 3 equations. I'm just going to come up with a random system. There's a system of 3 equations. Where do 3 equations with 3 unknown variables intersect at? And the answer is they intersect in a point. So 3 planes will intersect in a point. When you solve a system, if 2 of the equations overlap, there's a possibility that those 3 planes can intersect in a straight line. So we'll investigate that further later on as we learn more about 3 dimensions. So this is graphing a single point in a system. What if I want to graph a plane? Let's talk about graphing planes now. So I'm going to graph a single plane. 2x plus 3y plus z, let's just say equals 0. All right, I'm going to plug in some numbers so we can come up with 3 points that are on this plane. 3 points that are on the plane. And we typically will call these in 2 dimensions x and y intercepts. Well, now we got an x, y, and z intercept. Plug in 0, 0 for x and y. Instead of just 0 for x and 0 for y to find x and y intercepts, we're going to find the z-intercept. Let me give you something there. Let me get rid of all this. Let's call this 4. So plug 0 for x, 0 for y, z is 4. Let's plug in 0 for x and 0 for z. Plug in 0 here. 0. We got 3y plus z, 0. 3y equals 4. If 3y equals 4, y equals 4 divided by 3. 4 divided by 3, remember 6th grade? 1 1/3. Plug in 0 for y and 0 for z is our last point that we're going to graph. 0, 0 for y and z. Make these zeros here. 2x equals 4. So that means x is 2. X is 2. Now I can easily graph these points because each of them are on this space up here. 0, 0, 4. Go 0 in the x direction, 0 in the y direction, and then go up 4. Okay? So we don't go anywhere, we just go up 4 units. So there's a point. Go 0 in the x direction, we don't go anywhere here. Go 1.3 units, here's 1/2, so 1.3 units. And then 0 in the y direction, we're just right on that line. Or, I'm sorry, 0 in the z. The last point, go 2 in the x direction. Let's go 2, 1, 2. We're not going to go in the y direction, 0. We're not going to go in the z direction. Plot a point there. And now I'm going to try to graph this plane. Usually we use triangles to represent this. Graph a triangle. Right there. And I kind of shaded in slightly to show that this is kind of jumping out at us. And you gotta see that that's away from the graph. So that's graphing a plane in 3 dimensions. Your turn. Let's try one for you. See if you can figure it out. See if you can graph this plane.